Our goal in this tutorial is to give you a broad understanding of how multivibrators work. Also, we will not go into the deep details of the physics of electronic components or equivalent models. But we'll cover enough of the operation of multivibrators to understand how they can be used. At one of the previous videos, we have learned how to use a transistor as an electronic switch. At this video, we will see how a transistor can be used to switch another one. Bistable multivibrator using transistors. At the drawing you can see a pair of cross-coupled transistors. S, set, and R, a reset, are the input push buttons of the circuit, while Q and Q are the output clamps. While using a transistor as a switch, the state of the device can be either on, the voltage drop at the emitter collector line is nearly zero, or off, the voltage drop at the emitter collector line equals nearly the supply voltage of the circuit. So what happens if the left transistor, T1, is turned on? The base pin of T2 is connected via a series resistor to the collector pin of T1, so if the voltage drop at the emitter collector line of T1 is nearly zero, the voltage drop at the base pin of T2, and so the current running through those pins is also zero, hence T2 is turned off. While the voltage drop at the emitter collector line of T2 equals nearly the supply voltage, the voltage feedback passed to the base pin of T1, and so the current running through the base of T1 is at its maximum, causing T1 to be turned on. So the state of the circuit is stable. While T1 is turned on, T2 gets turned off, providing a feedback voltage which sustains the switching state of T1 on. The voltage drop at Q is zero, while those at Q' equals the supply voltage. The LED, which is optional, at Q' is turned on, while those at Q is turned off. What is happening while pushing button S? The current running through the base pin of T1 prior to this is now cut off, because the emitter base line of the transistor is shortened. Consequently, T1 is turned off, which is why the voltage drop at the emitter collector line increases to nearly the supply voltage. The voltage feedback passed to the base pin of T2 causes the right transistor to alter its state from off to on. Now that T2 is turned on, the feedback passed back to the base of T1 is zero. Even if the switch S is released, the circuit retains the switching state. Now the voltage drop at Q is nearly the supply voltage, while those at Q' is nearly zero. The LED at Q is turned on, those at Q' is turned off. Pushing button S once again doesn't alter the state of the whole circuit, because the base pin of T1 is already shortened by the emitter collector line of T2. While T2 is turned on and button R is pushed, the base pin of T2 gets shortened, altering the switching state of those transistor from on to off, which in turn alters the switching state of T1 from off to on. By pushing the S button, the output Q of the circuit is set, while it is reset by pushing the R button. Q' is the inverting output of the circuit. Whenever Q is set, the voltage output equals the supply voltage. Q' is reset, the voltage output is zero, and vice versa. The circuit is called flip-flop, latch or bistable multivibrator.